This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 2, Lesson 8, Pipe and Duct Insulation Requirements. This one is different. The handbook here does not give you a heat loss formula. It gives you code-style requirements, a minimum pipe insulation thickness table with an equivalent thickness equation for swapping materials, and a minimum duct R value table by climate zone. We'll read both tables, work the thickness equation once, and point you to the right place for an actual heat loss number. First, know what this section is. It answers how much insulation is required, not how much heat is lost. Two tools live here. A minimum pipe insulation thickness table you enter with fluid temperature and pipe size, and a minimum duct R value table you enter with climate zone and duct location. There is no pipe heat loss formula on these pages. Don't invent one. If you actually need the heat lost, that's a cylindrical conduction problem from Chapter 5, back in Fluids and Thermo, Week 3. The thickness table assumes an insulation whose conductivity falls in a stated range. Pick a material outside that range and you resize it with the equivalent thickness equation. New thickness equals the pipe outer radius times, in brackets, 1 plus T over R raised to the K over K power minus 1. Here, little r is the bare pipe outer radius, and little t is the thickness the table gave you. If the alternate is more conductive, capital K bigger than little k, the exponent climbs past 1, and the new thickness is larger. A worse insulator simply needs a thicker layer for the same protection. The problem. A hot water pipe runs at 220 design operating temperature, which lands in the table's 201 to 250 band. Conductivity range 0.27 to 0.30. Mean rating temperature 150. For its size, the table calls for 2.5 inches. You instead pick a material with conductivity 0.34 at that same 150 mean temperature, which is outside the range, so you resize it. The bare pipe outer radius is 1 inch. Solve. T over R is 2.5. K over K is 1.133. Raise 3.5 to that power, subtract 1, and multiply by the 1 inch radius. The equivalent thickness is about 3.1 inches. The more conductive material needs roughly a quarter more insulation than the table's 2.5 to hold the same performance. Round up to the next stocked thickness. The equation just sets the floor. The second tool is the duct R value table, a pure lookup, no formula. First pick the block, heating only supply, cooling only supply, or return. Then enter with the climate zone, 1 warm through 8 cold, and the duct location, exterior, ventilated attic, unconditioned space, buried, and so on, and read the required R value. A dash means no minimum is set. Heating duct minimums climb as the climate gets colder, and return ducts simplify to a single R3.5 for exposed runs in every zone. Now read it. A heating-only supply duct runs outdoors in climate zone 7. Go to the heating-only block, exterior column, zone 7 row. The minimum is R8. Check the trend. The same exterior duct in a milder zone 5 needs only R6, so more R as the climate gets colder. And any exposed return duct in every zone is just R3.5. So the zone 7 exterior heating supply duct must carry at least R8. Traps. 4 ways this bites. 1. There is no pipe heat loss formula on these pages. For the heat lost, drop back to the cylindrical resistance in Chapter 5. 2. Capital K is your alternate material, little k is the upper end of the table's range. Both read at the same mean temperature. Swapping them wrecks the exponent. 3. Little r is the bare pipe outer radius, the pipe zone OD over 2, not the insulation radius, and not a nominal size, the most common misread. 4. The duct R value excludes the air films and is only an efficiency floor. Condensation control can require more. Quick recall. 2 lookups. Pipe. Read the minimum thickness from fluid temperature and pipe size. And if your material is off range, resize it with the equivalent thickness equation. Capital K the alternate. Little k the upper range value. Little r the bare pipe radius. Duct. Read the minimum R value from climate zone and duct location. The heat loss itself is not here. It's the cylindrical resistance back in Chapter 5. Golden rule. This section sets requirements. For a heat loss number, leave it, and use Chapter 5. Next, Lesson 9, Block Load Assembly and the Load Estimate. You now have every component: envelope, fenestration, internal gains, infiltration, ventilation, and today's insulation requirements. We stitch them into a single peak block load, mind the timing so the parts add at the right moment, and frame it with the Handbook space, heat, and moisture balance. Everything's at PEPrepEngine.com. Cheat sheet, work solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at PEPrepEngine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.